Good afternoon, everybody, and thank you very much for this opportunity to talk to you. It's when you get introductions like that and somebody mentions that on your CV you used to work for GEC that you realise how old you are getting. For those of you who are not from the UK, GEC is a company whose origins go back to the 20s or 30s. I'm looking at Alan because he was there at the founding. So what I'm going to do this afternoon is I'm not going to dive into a great deal of technical detail about remote sensing. So if you feel that you've been missold this, then I do apologise for that. What I've been asked to do here is to set the scene, to pick up the theme about the cluster of activities here in Scotland that is based around photonics and optronics, and put that in the context of a wider sensors cluster. And then to talk about the innovation centres, give you a little bit of context about what they are and what they do, and then focus on my innovation centre, which focuses on sensors and imaging systems. We're going to touch on some of the projects, so it'll give you a flavour for some of the technologies and expertise that we're working on locally, and hopefully it'll spur your interest in maybe looking at partnering with academic partners and industrial partners here locally in Scotland to do something exciting in that area. A theme which picks up on the overall theme of the day, which is about maturing and accelerating the uptake of technologies in the industrial base, also runs in parallel with that. Now, I've been given this, and I've been told under no circumstances press the buttons at the top, so let's see if I can manage to avoid doing that, at least for the first slide. So what I'm going to talk about, as I said, is an introduction to the Innovation Centres programme, tell you a little bit about what they are and what they do. I'm then going to really start majoring on CENSIS, what we do, how we do it, what our markets are, what the technology trends that we're interested in, and where the challenges are in terms of that technical acceleration. And then I'm going to pick up some highlights. We've been going for about 3 years, so there were a limited number of highlights to date, but I just want to pick up on some of the highlights to date and set the scene for where we might go in the future. So, first of all, the Innovation Centres programme. The Innovation Centres programme, there are 8 innovation centres in Scotland, and they're organisations that were formed with a core grant from the Scottish Funding Council. For those of you who are not local, the Scottish Funding Council funds research activities in the Scottish academic base. £120 million of core funding over 5 years. So basically what you're looking at is 8 centres, some of that is capital, so you're looking at a sort of running budget of about £2.5 million a year for each of these 8 innovation centres to get on and do stuff, and we'll talk about what that is in a minute. The thing that sticks in my mind is that one of the people on the organising committee who steered this through is president, or was then president of the Royal Society of Edinburgh, and talked about it being an investment, not a grant, and the government wants a return. Now, I don't know about you guys, but if you've hung around here long enough, you know that when a Scotsman tells you, hey, I'm lending you this money and I'm expecting it back, you sit up and listen. So, that tends to get a laugh, that line, but that's mostly in Glasgow, I guess. So, let's talk a little bit about these innovation centres. What are they? What are they about? So the Scottish Funding Council decided that we have a disproportionately large academic research base in Scotland. It's jam-packed full of research-intensive institutions, and they're doing excellent work. There are world-leading scientists, world-leading researchers, very high-performing, lots of papers, lots of academic output, and they wanted to make sure that that was reflected in a vibrant technology base, So one of the things that we're looking at is that hairy old chestnut, that perennial problem of how do we take clever stuff out of universities, help mature it, inject it into the industry base, and get an economic return for that. So they set up 8 innovation centres, roughly about the same time. There are 6 of them along the bottom, if I could just go through there. And what they do is they focus on industry verticals. So the construction industry one does what it says on the tin. It brings innovation into the construction industry in Scotland. Some of the others, however, have a major problem owner. Digital healthcare works to the NHS in Scotland and looks at solving the conundrum of meeting an aging population with limited resources. There are two at the top here, CENSIS, which I'm going to talk about in a minute, and the Data Lab, which looks at big data. And these are cross-cutting, so they're working with base technologies that can be applied in a number of sectors. That brings its own challenges with it, but it also creates some exciting opportunities, which we want to explore. All the innovation centres, to varying degrees, have three tools in the toolbox. One of them is a skills agenda. The other one is a strategic outreach agenda, bringing partners together across industries, within industries, industry and academia, working on specific bespoke workshops to identify sector problems, and generally doing the brokerage around that sort of activity. The third thing, which is front and centre of what they all do, is collaborative research projects. Now, because we're funded by the Scottish Funding Council, that means we can only fund projects in universities. So a typical project for an innovation centre tends to look like one industrial partner, one academic partner, overall to square the state aid conundrum. It's 50% industry, which the industrial partner funds, and it's 50% academic, which we can fund up to a certain level. We do have an example of a much more complex project structure, which is a blueprint we'd like to take forward, and I'll touch on that a little bit later. So, CENSIS, what does it do with the tools it has in its toolbox? What's it trying to do? Well, it's trying to help industrial companies optimize their R&D portfolio, make sensible choices about R&D, to enable new products and access to new markets. It's all about making those technology decisions sensibly and in a timely manner to help reduce cost, risk, and time to market. And it's ultimately, and this is where the economic value is created, looking at how we can position the various actors in that train that takes exciting technology from the academic base into industry, position it such that we anchor the high value elements, the knowledge intensive elements of any future supply chain in the local region in Scotland. And of course, some of the other innovation centres, it's a little bit more important than it is for us, but it's a balance, also address wider societal challenges as well as challenges around the economic environment. And last but certainly not least, it's to work with the academic base to help them shape their research agendas and also to demonstrate impact, which is a key thing for future funding streams for the academic base. We happen to have a footprint in Glasgow and Aberdeen. That serves us quite well. We work across Scotland, however. So let me pick up on the sensor and imaging systems marketplace. Why is it of interest? Why would you spend money on having an innovation centre here? Well, first up, it's an interesting global market. These figures are probably about 2 years old now, so I think you're looking at about $750 million market worldwide, of which the lion's share is systems, sensor and imaging systems, and that 70, about a tenth of it is to do with components, sensor components. In Scotland, there is a cluster of about 170 to 200 companies who do sensor. They make sensor components, they make sensor systems. So we're just talking about making the sensor system at this stage, and they account for about £2.6 billion worth of activity in Scotland. Not bad. A lot of that's driven by export business of oil and gas technologies into the wider oil and gas exploration and exploitation marketplace. There are research activities, actually our database now contains more than that. There are probably about 120 research groups across about 13 universities which are involved in some ways in sensor technologies, okay, of which photonics is a key area. They employ about 16,000 people, high-value jobs in Scotland, and it's an important sector. But frankly, that's nothing to the economic benefits that accrue. This is just the tip of an iceberg when people pick up these sensor solutions and apply them in end markets where there's a measurement problem or a control problem. For example, you look at that marketplace and you say, okay, that's reasonable numbers, but let's just take, for example, the application of some of these sensor systems into smart grids, smart cities. Let's look at smart grids, for example. If using these sensor systems, you can cut the losses on the, transmission lines across the UK by even 0.001%, you are talking about hundreds of millions of dollars of pounds worth of savings, and you're talking about a considerable impact to the carbon footprint. So the message from this is the real value of sensor and image systems accrues when they get picked up and used in the end applications marketplaces. We call this the pizza slice diagram. I'm not sure, I've never had toppings like this on mine, but it's to explore here those sectors in Scotland where sensors can be used. And the first thing you notice about it, and if you did a pizza slice for any other place, you'd notice the same thing, which is sensors are genuinely ubiquitous now. So what we've tried to highlight here is sectors that are of economic importance to Scotland. So we're looking at the offshore sector, offshore renewable energies, oil and gas exploration. We're looking at the industrial base, power management, smart grids, industrial processes, manufacturing. We're looking at smart cities, smart transport systems, monitoring air quality, things like that. And finally, this patch here, a bit late to the party, but this is the rural environment. There is a huge opportunity here in Scotland to look at the application of sensor systems and then big data paradigms to the data that you collect from the sensor systems in a topic area known as precision agriculture, the application of these technologies to the improvement of land usage, crop yields, and animal husbandry. It's a fantastically interesting marketplace. Technology-wise, this is our view of the technology world. Here's our stack. Sensor element might be a humble thermocouple, could be an optical sensor, could be a camera. Then we move up the stack, you're talking about packaging it, possibly for hostile environments, such as the offshore industry. You're looking at signal conditioning, getting something sensible out of it. Then you're looking at connecting networks of sensors. You're doing post-processing, analysis, and data visualization, moving from raw data up to genuine information on which you can make decisions. We've been working with this model for some time, and we're now starting to build up a picture of where the key technology trends are. Do you remember when I showed you those numbers for the worldwide market in sensor and imaging systems? There was a compound annual growth figure of about 10%. That's the aggregate figure. There are slices you can take through that data where the growth rates are much, much higher. For example, if you look at low power systems or energy scavenging systems to support sensors, if you're looking at intelligence at the node, if you take a slice through that marketplace based on end application, for example, subsea and offshore, you'll see growth rates up at 40%, and that's driving a lot of innovation and the demand for new solutions. So, what we've done in our project portfolio, and again, this needs updating. We have some 38 projects now, but to date, let's just work with this slide. We've got 34 projects on the slide. That's how they pan out across sectors. Interestingly enough, you'll see a lot of activity here and an increasing amount of activity here in environmental monitoring for natural and built environment. What we'd like to see is a growth in the defence opportunities. We have one project to date, which I'll give you a brief overview of a little bit later on, but there are a phenomenal amount of opportunities to really expand that sector for us. One of the things that we are able to represent here is, if you take this blue profile, that's the profile of key technologies in each project at the start of those 34 projects. if you look at this profile, that is the profile either actual or projected for the technology readiness of those same key technologies after the project's complete. So you've got this steady maturation of technologies from 2 to 3 up to 6 to 7, which is exactly what we're about and meant to be doing. So let me just touch on now, if I may, a couple of projects of interest. So here's the counterexample to that very simple project that I showed you. Here's one that has several industrial partners, has at its core a strategic research program with a local university. And basically, the partners, the industrial partners, are working to define the requirements for the technology. The strategic research program delivers that, and then the partners are free to exploit that technology in each of their specialist areas. As they work in different markets with different products, that manages the risk of the project nicely. This project has £250,000 worth of investment for CENSIS, £2.5 million worth of investment from Scottish Enterprise. Overall, it's a £6 million project. It's to develop compound semiconductor technologies for optical sensors, mid-IR sensors predominantly. And it has, my apologies for that, it has a model of long-term economic benefit that actually demonstrates that it will reshore some advanced manufacturing jobs back here. So let's quickly, so that you just get a flavour of what's going on, pick some of the smaller projects that we have. Here's an interesting one here which looks at fugitive gas emissions, possibly from a fracking site or a landfill site. It uses line-of-sight laser technology. At the same time, you're looking at the absorption along the pathway of a couple of lines of the laser. You're measuring wind speed and wind direction, and you're doing some clever algorithmic work, and you're producing a 3D map of the distribution of gas emissions. Here's a project here which involved AECOM company and the United Kingdom Astronomy Technology Centre in Edinburgh, which is looking at the application of hyperspectral imaging techniques for measuring water quality. This is well understood and has been done lots of times. The challenge with this project was they wanted to verify that you could use these remote sensing techniques for looking at shallow and small bodies of water, mostly urban drainage systems and urban water management. A project which demonstrated its utility for this, but there is much more additional work needed. Normally at this stage, I see people's eyes light up and they say, hyperspectral imaging, that's interesting, I'll ask some questions about it, and that's where I normally founder. However, I'm happy to say that the next speaker is one of the world's leading experts in hyperspectral imaging, and will be able to answer all those questions for you. Here's an example which also might be close to some of your hearts. This is an example of working with Thales and the University of Glasgow and Thales and the University of Scotland, West of Scotland, and CENSIS are involved as well. And here the project is about taking low quality thermal imaging, doing the heavy lifting in terms of the algorithms and doing auto detection and recognition in that domain, all managed to cost and managed to making the hardware that the clever algorithms have to run on manageable for a portable solution. Here's another example which is quite different, but it may have some technical resonances with you. This is a local company that develops retinal eye scanning. The trick with retinal eye scanning is to maximize the coverage of the back of the eyeball, and to do so without sacrificing quality, but to do it quickly, because the machines are very capital intensive and you want to keep refreshing the use of that machine very quickly. So here's some work that was put together with a group at Glasgow which are working on spatial light modulation, that we're able to help develop a new optical system to deliver those improvements. So we're coming to the end now, you'll be glad to know. So some of the future developments that we're looking at is, I've mentioned the database that we maintain of research expertise here. We had detected in the environment lots of great capability in the academic base, lots of interest in the industrial base for Internet of Things-based solutions. So Internet of Things paradigm applied to end-to-end sensor systems to deliver rapid prototyping of the systems. But there was a missing piece, and we've put in place a piece of real physical infrastructure supported by IBM, Microsoft, HP, Stream Technologies, which is a local firm, who've all contributed to putting in free of charge software, hardware, and expertise into that sensor. We bring academics and industrialists together to help deliver accelerated technology solutions. We have just announced putting in place a wide area low power network in Glasgow. We have a 12-kilometre square area with this LoRa network in. The LoRa network will be available for people to come and plug solutions in, demonstrate interoperability, and help mature products and technologies through to ultimate release. So we have, and this is a commercial break, and I do apologize for this, but I wanted to flag this up because it does illustrate the strength of the community here. We run a technical summit every year at CENSIS. This year we have 480 people who want to come, and they're going to be talking about sensor and sensor systems in a connected world. Final slide is just to say, to summarize what we've talked about. We've talked about maturing and accelerating technologies. We've talked about the size of the technology portfolio. We've talked about the sectors in which it is active. We've talked about the community that we're reaching out to, 3,500 companies in our database. And we're talking about building real assets to help people accelerate technology solutions. Our international outreach is beginning to build as well. Thank you very much for your time, and any questions?